In this video, we're going to look at how to make data visualizations when you want to show parts of a whole. So if we have one question, one survey question, or one field of data, we can create a donut, a pie chart, or a tree map. Now, if your data is nominal, so it's categories, then you can create the donut, pie chart, or tree map. If the data is ordinal, so it is ranking, then we want to create a donut or a pie chart. The tree map is not relevant. So let's take a look at how to do that in Python. So just a reminder, we are working through the Python workbook that you can find in drstephpowers.github.io/BIA, and we're working through the one called data visualization. So click here, it'll open in GitHub. You can then open in Google Colab. Make sure you log into your Google Drive and save a copy so that you can run the code and edit the code. You also need access to the Excel files, which you can find by clicking here under data visualization. And then as we've talked about in previous videos, you'll need to mount your drive, your Google Drive, and then save those Excel files to your Google Drive and link to them. So we're using Bargain Numeric, Bargain Clean, and CRM Clean. All right, let's start by creating a pie chart. To create a pie chart, we are going to use matplotlib.pyplot, and we're going to call it PLT for short. So import matplotlib.pyplot as PLT, and then as we manipulate our data into tables and other forms, we will need pandas, so we're going to import pandas as PD. We're going to be using the original bargaining data set, so it is not coded. And so if we type in df.head, oh, I haven't mounted my drive. So let's do that. Remember, you're just giving access to your Google Colab, to your Google Drive. You're not giving access to other people when you do this. All right, come on. So we've imported our packages. Let's quickly import our data because obviously I did not do that. Makes it really hard to analyze it without it. What we're going to be using here in our first star pie chart is this Bargain Clean. We cleaned it in a previous video. It is not coded, so it's not this numeric one. And so when we do look at it, what we see here is that there are a number of variables that have text, including question 2, which asks people if they are full-time or part-time. So we could create a pie chart to show the breakdown of respondents in our survey. How many full-time, how many part-time. If we are doing this from data that is text, then what we need to do is we need to reclassify that variable as a category. So in our previous videos, we've talked about floats and integers and Boolean, different types of Python data. Here we're going to use a new one called category. So we're going to take question 2 in our table DF, and we're going to change the type to category, and then we're going to apply it to that variable. Then what we're going to do is have it identify those categories. So we're going to call that cat. And so it's going to take question 2 and it's going to find the categories using this cat.categories command. And what we can then do is we can pull that information as a list. So we take the list of categories and we'll call that cat_Q2. So when you do that step, what you find is full-time and part-time. This set of code that you have here we'll use later for variables that have a lot of different options. And so we're basically just going to keep this kind of code and then replace in the Q2 for other variables if we want to identify the list of categories for a particular variable. So then what we want to do is we want to create a pie chart, which is plt.pie. You need to specify what it is that's being plotted. And so what we're going to do is that value counts command that we've used before when we wanted to calculate frequency. And so we're going to take our data frame, our table DF, find the value counts, so count how many fall into each category. We're going to get that for question 2. And then we want labels. So the reason we did this categorization up here is so that we can use those labels here in our pie chart. So our labels are going to be equal to the list of categories that were found. You can change this portion here, this auto PCT. Really what we're doing is we're changing the layout of these labels in terms of spacing. And then colors, and we'll change the colors in just a moment, but let's say we start with light green and light blue, and then we run this, we have that here. If you want different colors, there's quite a lot of choices. You can do different colors, so let's go from the light ones to the non-light ones. And you can see that they're darker here. So we tend to go on the lighter side just so it's easier to read the text, but you can pick whatever colors match, say, the dashboard that you are creating. So probably not pink and red, but let's just show you here. You can change out to whatever colors that you want it to be. So here we only had two labels. We had part-time and full-time, so we're only specifying two colors. If you have more labels, you're going to need to specify more colors. Now, you can, when you create a pie chart, you can add your own labels. So if you didn't do this kind of category here, we could instead do or specify our own labels rather than doing the step where it identifies the different categories. So if we were to do that, then the code changes here. We still need our value counts from our data table. So for example, this one is coming from the bargain numeric table, so DF2, and that's the coded one. So if you recall back, and actually let's just load it up here. Let's look at df2.head. What you can see for question 2 is you can see it's coded, so we have 1 for part-time and 2 for full-time. So if you're using a coded data set, then we'll need to provide it with some labels. So we'll need to give it some names. So here we're going to do the value counts. How many people responded 1, how many people responded 2. And you can do sort index. Okay, so if you don't do sort index, what it does is it will take whatever appears first in your table, and that's going to be the first value count it gives, and then whatever appears next. Well, that's really hard for us to keep track because we are only just looking at the first couple rows here, and what if we had more than just 2 categories? Plus, if we're going to be putting our labels on, it's probably easy for us to actually just order these so that we know how many people chose 1 first, then how many people chose 2, and so on. So this sort index here helps us in terms of that ordering so that we can make the labels part-time and then full-time. If you don't do sort index and 2 appears first, then the challenge will be is your labels are not going to match the actual data. So one of the risks with this approach here is that you got to make sure that the data and the labels appear in the same order. You can always check that, of course, by just having it tell you the value counts first, and you can see on the table what it looks like. So the rest of this is the same. We have some formatting here in terms of where the size and how far apart our labels are from each other. We have some colors. The key here is that the labels changes from before, where the labels was the categories list, to ones that we specify. So part-time, full-time, we just got to make sure that it's in the same order as the value count. So here's our part-time and here's our full-time. Okay, the second type of data visualization that we can use to compare to a whole is a donut. So a donut is like a pie chart, except for we take the middle out. And we see more and more of the donut type charts in dashboards and visualizations. People find them a bit more appealing than the old traditional pie chart. So how do you make one in Python? Well, we're going to import matplotlib.pyplot as PLT. Okay, we're going to do the same steps in terms of having it find categories. Here we're using our coded data set, and we're going to use question 1. So here we have, let's go back to our survey, what should be the top priority for the next round of bargaining? So improved benefits was 1, improved working conditions was 2, job security was 3, and of course we had created in our coded version so that 7 was other, and then we had that separate variable where we could have the write-in responses. So we've coded it 1 through 7, and we're using that coded instead of the original clean data set because of this other, right? Because we have this other spot and we don't want all those responses to get a sliver of the donut. We want to combine all the writing responses together on our donut. So we're using the coded version, DF2. We're going to need to classify it as categories. So the same step as we just did with our pie chart, as type category, and then identify those categories and put it into a list. In this case, what we have is 1, 2, 3, and 5. So if we go back here, what we have is improved benefits, improved working conditions, job security, and pay. Nobody put as the top priority relationships between union and company. Okay. To create our donut chart, we use the same plt.py as we did with pie chart. And then we need to specify what table and what variable we're using. So we're going to use df2 here. That's the coded data table, df2. And we're going to do value counts. So find out how many people fall into each of those categories. Don't forget to sort underscore index. We're going to need to do it like that, just like we had before. Same thing as you did with the pie chart. So don't forget the sort underscore index. The reason, of course, that's so important is because the labels need to match the order of the data. Now, in this case, notice the labels here, we've written out the names of the labels, even though we have used the command up here to find the categories. And the reason we're doing both in this case is because when we identify the categories for question 1, again, we're using the coded one to deal with that open-ended question response, just being all coded to 7, so that these are all put together in the donut chart. And then we see here when we do this is that no one actually wrote anything in, but there's also no number 4. And so the reason we pull the categories is we realize that 1, 2, 3, and 5 are the categories that people chose. And so our labels need to be category name for 1, category name for 2, category name for 3, and for 5. So by pulling this information, we can see the labels need to be improved benefits, improved working conditions, job security, and increasing pay. Now, don't forget that sort underscore index, because that's going to make it the order of 1, 2, 3, 5 instead of the order that it appears in terms of number of responses. And so what we have here is we want it to match. Then we're going to specify here a number of things just for formatting. This is going to be related to size of text, how far the text is from the edges of the image. And then you have this explode here. The explode piece is to create these separations between the different categories. And so what we want to do is we want to make sure that we're doing that separation. So the number of 0.05s you put in this explode should match the number of labels that you have. So if we had 5 labels, we need to add another 0.05. The rest of this, you'll be able to keep the code as is for future graphing. What it does is it creates a center circle that is in the center at 0, 0. Here, this is specifying the size of the circle and that the color is white. It is going to then take that center circle and we are going to add it to our original graph and we're going to output it. So let's just do that. And we can see in this case, increasing pay is the most important to our survey respondents, and then improving working conditions and benefits, job security there as well. So we have our pie chart, we have our donut chart. Why don't you take a moment, pause the video, and create a pie chart and a donut chart for question 6. So if we go back to our survey, what we find, stop doing that, come on. Question 6 says, how satisfied are you with the current salary and wages? So here, instead of nominal, we have ordinal data. And so we can create a pie chart and a donut chart with these with this ordinal data, with this Likert scale question. So let's do that. Pause the video, try it yourself right here, and then we'll see how it went. All right, to create our pie chart here, this is question 6. We're going to need our labels here. So we're just taking the same code as before, trading out all the 2s for 6s. Okay. And so even though the scale was 1 through 5, notice that our responses are only 1, 2, 3, and 4. So when we look at question 6, how satisfied are you with current salary? We have completely dissatisfied, dissatisfied, neither, and satisfied. No one is completely satisfied with their pay. All right, to turn this into a pie chart, we can either do it where we provide the labels or where it does the labeling. Notice here. Notice if we use DF, the uncoded survey, and we enter in our code, let's say we do plt.py df.value counts. If we enter the labels here as cat q6 and we plot that information, then notice we have 1, 2, 3, and 4. And what we really want to know is what 1, 2, 3, and 4 are. So rather than put labels equals cat6, we do want to write in the information, and we want to then do, just like we did previously, we're going to want to do sort index, and then specify what those labels are to make sure that information matches. So let's do sort index, 1 dot here, and then change the labels to be what in question 6. So if we go back to our set here, question 6, completely dissatisfied, dissatisfied, neither. So we want this to match, so we're going to go completely dissatisfied and then satisfied or dissatisfied. And then we have 3, which was neutral. And then we have satisfied. And again, we don't have any completely satisfied here. Now we have our formatting for the colors. I'm just going to remove what I've put here. So just remove that for a second here. So the challenge, of course, with Likert scale is that if we leave the colors up to however it format itself, then the colors don't quite match. You know, completely dissatisfied here is blue, but dissatisfied is orange. Does that match how we think about the scale? So you probably want to change your colors so that it gets darker of the same color as you get more negative, and darker of another color as you get more positive, and then the neutral color something in between. So you want kind of this gradient when you are doing Likert scale with your charts. To change the color, what you would do is you would say, let's just return this here, colors equal, and then you can specify what those colors are. And so what you see here are HTML color codes, and you can just Google HTML color codes. Websites like this have it where you can just click on the color, whatever shade you want, and it gives you the hex code. And so you'll just want to pull the hex codes. You can also find websites where you can kind of click on, maybe you have other things, colors that are in your brand, and so you can then match those colors and get the hex codes for that particular set of colors. So I could pick a hex code for something that's a bit more red to be my completely dissatisfied, and I can move closer and closer to say blue for my completely satisfied. And so I would just pull these codes, that's what you see up here, and then that means that when I run it here, all right, what's upset? All right, I got too many parentheses. There we go. So we'll run that. And so then what we should see is that there should be some kind of scale to it. I didn't pick very good colors here. My completely dissatisfied is some kind of orange. So my dissatisfied should be, oh, The problem is I need 5. So let's go and let's grab an even darker color here. Let's try this one for 1. Okay, so make sure we have 1, 2, 3, 4 labels. I need 4 colors. I'm going to remove this bright green one. That should be this one right here. Let's give that a try. So we can see the completely dissatisfied is dark red, then a lighter red. Probably want to change the neutral to something that's not so blue. And then as we move towards satisfied, we start to see it. So you can use pie charts for ordinal data, maybe not the best choice. It's better with nominal, but you can see as you change the color scheme, you can get a bit of information. Now let's repeat this, but let's actually do it with a donut. So to do the donut, we'll use those same categories. We'll use our same information here. We'll just copy this code. So I'm going to copy this. And we already have coded data in DF, right? Because the Likert scale. So we can use the DF, the value counts. This is question 6. We are doing sort index. We can copy our same labels that we put in the previous one here into our donut. And we have 1, 2, 3, 4 categories. So our explode is 1, 2, 3, 4. We can pull the colors over. So if you find some colors that you're happy with, we can pull those in because both of these use the same .pi. So they're the same formatting here. And then we keep the rest, right? We keep our white center. We keep the exploded out. And let's run that. Unexpected labels, that's because there's 2 L's there and there should be 1. All right, there we go. And so we can see here we have the completely dissatisfied at 7.9, the dissatisfied at 44.4, and then you can see the satisfied at 15.9. Don't forget to sort that index so that it matches the order. And then we, of course, have the categories at the beginning, 1, 2, 3, 4, so we know what labels to put there. So we've created our pie chart and our donut here for our nominal data. All right, in terms of parts of a whole, the third option, and it only really works with nominal, is what is called a tree map. And the tree map uses matplotlib.pyplot as PLT. We're going to import pandas as PD, and the tree map uses a package called Squarify. It makes these, and so we need to import it because it's not already in Python here. So we'll do a pip install to import that package. We'll install that package first, and then we will import it. Okay. Now, when we build tree maps, so let's say we're taking question 4. And question 4 in our survey is which healthcare benefits should be prioritized for an increase? Wellness account, health spending account, massage, chiropractor, and this had the other in it as well. And if we are using the original data set here, so it is not been coded, then when we do as type categories and we do our categories here, all the write-ins will appear here: greater coverage of orthodontics, maternity leave top-up pay. These additional write-ins all show up as categories with one person attached to them. If we did that, so we left it with our other, although included, and then we created our tree map, we would use squarify.plot. And we're pulling from the original data frame DF. We do value counts for all of these. Value counts for question 4. We do want to sort it. Okay. Here, if it's not coded, it's sorting here to be alphabetical. And so because we don't want to rewrite all this stuff out, we do label equals cat Q4. And then we have some formatting things. Here's alpha equals 0.8, and we're going to plot the axis. We're going to have that off because we don't need labels on the axes. And we get a tree map that looks like this. It's a bit messy. If you re-roll it, you can get different color schemes here. But you'll notice that some of these write-in responses are quite long and take up a lot of space. So simply doing categories from uncoded data makes the tree map a bit messy looking. So a better approach would be to use the coded data where we have bundled the others into a code 7. So here we have df2 value counts, Q4A, and we sort them so that they're coded 1, 2, 3, 4, 5. That helps us as well because we know this order: wellness account, health spending account, massage, and so on. And so if we do the coded and we look at here's the counts, then when we do our tree map, we will provide the labels. Okay, so we're going to do df2 value counts, and we make sure we always do sort index so the order matches. Sort underscore index, parentheses. Okay, and then we need to be in the same order as 1, 2, 3, 5, 7. So number 1 is wellness, number 2 is health spending account, number 2 is HSA, number 3 is massage. Okay, number 5. 1, 2, 3, 4 is dental. And then 6 is our drug coverage. And then the last one was other. Okay, so do sort index, and that way you can write the labels in the order that you've coded them, 1, 2, 3, 5, 6, 7. This makes it easier to match them. Otherwise, if you don't do sort index, you have to go, okay, which one was the biggest? That's going to appear first. That was drugs, then the next one, and so on. So what we're doing here is we're cleaning it up and making short labels. And so this tree map then shows us that drugs are the most important because it's the biggest portion of our map here. And then the next is the wellness account. And so if you don't like the color scheme, you can change it or re-roll it to get a combination that you like. So the tree maps are really only going to work with nominal data. And again, they're showing parts of a whole because we're looking for which is the biggest part, second biggest part, which ones are smallest. So before we wrap up this video here, can you create a tree map for question 23? So question 23 in our survey asked, what campus are you associated with, north, south, east? So to create a tree map, pause this video and see if you can create one. So if we're using the coded data, then we can do our value counts and sort. We can then plot using Squarify. df2 value counts question 23, have it sort index so that it matches. And then the order that we're looking at here is the first one was north, then south, then east. So this one only has 3 categories, so it'll be a very simple map here. And we would expect it to be a third, a third, a third, and you can see that it's approximately that way, although it looks like the south might have a little bit more respondents than the other 2 categories, but not a huge amount.